Okay, this is a quick overview of the virtual analog plugin that I'm developing for the K2. This is a host side application which does some simple stuff, loads the plugin into the K2, and then pulls MIDI input and processes the events, sends code over to the plugin so that the tones can be generated. So here's the MIDI handler. What the note's on, it's going to write to the SCI register on the vs1053b with the note and velocity. And when you lift your finger off the note, then it's going to send the note and a velocity of 0, which will stop the note. On the V-side side of this, where you develop the plugin, there is some setup code for putting a pointer to the code that processes those commands that get written to the AICTRL registers. And there's also a DAC interrupt. So this has got a little trampoline that saves away a bunch of registers and then calls C code. And then when the C code is done, it restores everything and returns back to the chip or whatever, the normal chip operating system. So let's take a look at the control side. So right now I have, when you first bring up the chip, it's going to reset all these voices, and I have it set up hard-coded to be set to saw and square wave for the two oscillators that are in here. And then you can send commands to start processing of the voices. So it has this DAC enabled variable that's sort of a global that the interrupt looks at to determine if it's going to do anything or not. And then there's a way to reset voices. When a note is received, it uses voice stealing. So there's code to monitor the number of active voices, to track the age of a particular voice. And if you're out of voices, then it will find the oldest voice and use that value. And it stores this in a voices table, which includes the note to phase increment, which is used to set the pitch for the particular note. So let me just show you in these tables. So we have wave tables that provide the amplitudes for the waves over the course of the waveforms, triangle, square, saw. And then this phase table basically tells you for a given note how many jumps you make in the table in order to select the right amplitude for a given sample. ISR service. This is what runs at 44 kilohertz right now. I may reduce that in order to have more processing time to add more features. So I may run it like at 36 or maybe even lower that, but right now it's set up for 44. And yeah, so this is what it does. It goes through and looks at all the voices that are on and adds them together. Uses some division, stupid division right now, just the simplest division to prevent overflow when it gets written to the DAC. And what it does, if it's in plug-in compile mode, then it takes that mixed sample and writes it to the DAC. Simple as that. If you're not in plug-in mode, it has this global left sample, right sample variable that's used. So when developing the plugin, I have it set up so that you can simulate writing to the different registers and writing a wave file. So it's possible to simulate different notes and so forth, write the samples, at the at a particular count of samples. So just take those tones that have been set up using these register calls, and we'll output that to a wave file. And then when you close it, it updates the header for the exact length of the file. So this is really allow you to do it where you don't have to do the round trip back to the host to see if the thing is working properly. That's more or less it. So let's take a look at this thing, where it is now. All right, so that's that. Let me open, I've got to open Reaper. Okay, here we go. Let's see if this works. so it doesn't really properly close the or turn off all the notes when I stop in Reaper because I've set it up that way. So what I had to do is I'm running this interface through a Kai MPK Mini version 4, and what it does, it allows you to go in through the USB interface to the Akai Mini and have it route any MIDI that comes in through that out through the DIN connector, and I have that DIN connector going to the K2. So that's sort of my routing setup. So it allows me, if I set up the MPK Mini to internal mode, then I can use the keyboard to play the notes, that kind of thing. Or if I have it in USB mode, then it will route it through the other way. So yeah, that's more or less it. So I'd say watch this space. You know, I'm really just trying to figure out exactly what I want to do here. My original plan was to do something like a subsequent 37. There's examples of people writing plugins that are like that. So that would be like a monophonic or paraphonic with 3 oscillators and so forth. But I might be, kind of far away from getting that because I have to do things like implement some interpolation for for the different samples. So when you do wavetable lookup for a given offset that may not fit exactly between, on one of the samples that is in the table, then I'm gonna have to do some like linear interpolation to get what the value should be. I want to add, I'd like to add some, I have to add like a Moog filter, something like that. So there's examples of code that you can make to use that. So there's, it's actually some things have been written for DSPs. And I hope to leverage some of that code and hopefully get something to work, and hopefully I can keep the sample rate high enough to where it sounds good. Right now there's 0 filtering, so you may, when I was playing this thing back, you would hear like some chirp sounds. So I assume that's, when I shut things off hard, that the DAC is probably has some ringing or something like that, or it looks like a step function. It's probably just creating a crackle at that point. So we'll see. A bunch of stuff to implement, and we'll see how much I can fit in there. See you next time.